All right, so the first part of today's lesson is talking about using a visual representation to help you solve your probability questions. Um, on your notes, it talks about the first one is tossing a coin twice. So anytime you toss a coin, you have the option of heads or tails. So if you toss it twice, you could get heads, heads, tails, tails, heads, tails, tails, heads. And why would that be helpful? Because maybe the question says, what's the likelihood or what's the probability of getting the same thing both times? Okay, well, which ones of these are the same thing both times? That one and that one. So if I want the probability of the same thing twice, from looking at the diagram, I can see that that could happen twice out of 4 possibilities. So I could write it like that. I could simplify it to 1/2. Okay. Super, super common phrase that we are going to use this year is this one. What is the probability of getting at least one tail? What is the probability of getting at least one tail? How many of those have at least one tail in them? Does this one? No. Does this one? Does this one? And does this one? So probability of at least one tail is 3 out of 4. Good. Also, just because this comes up later, so we might as well talk about it now to make it clear. What is the probability of getting tails on the first or tails on the second? Does this one have tails on the first or tails on the second? No. Does this one have tails on the first or tails on the second? Yeah. Does this one? Yeah. Does this one? Yeah. So these are actually asking the exact same question. Okay? 2 different ways to word it, but those are the same question when we boil it all down. Okay? Then there's the layout for rolling a die. Rolling a die once is not a very exciting layout. It's just the numbers 1 through 6. But rolling a die twice, it's super helpful to have like a diagram or a layout of what's happening there. Because a lot of times we want to know things like, what is the probability that the sum equals 5? So look at that huge layout, all those numbers. How often does the sum of the 2 die equal 5? Can you find them? How many are there? Silent treatment. Got it. How many times does the sum equal 5? I think there's only 4 of them, right? So 4 and 1 would equal 5. 3 and 2, 2 and 3, and 1 and 4 would add up to 5. Okay? So there are 4 out of how many are there total? How many outcomes are possible when you roll the die twice? 36. Good. So you could leave it like that. You could simplify that fraction if you wanted. You could turn it into a percentage if you wanted, whatever you want. Okay? What is the probability that the sum is 12? Is that very likely that you roll 2 dice and you get a sum of 12? No, that only happens once, right? In all of those possible outcomes, that only happens once. So what is the probability? One success out of how many possible? Out of 36 possible outcomes. Any questions so far? I don't know if you guys don't know the answers, like if you don't understand what I'm writing, or if you just don't want to talk because there's 6 of you, 7 of you. It's getting a little awkward for me though, so if you could like liven it up just a tinge, that would be great. No? Okay. All right. That was fun. Okay. So, yeah, sometimes the diagrams are just helpful for you so that you can just count the number of successes and divide it by the number of possible outcomes. The next thing we're going to talk about is a vocabulary word that is going to be super, super important. Also, it seems to be a vocabulary word and a concept that my students have traditionally struggled with. You will see at the end, in the questions that I ask as I wrap up this note guide, that the big confusion is generally between this concept of mutually exclusive and the concept that we covered last time, which is called independence. Okay? So there's independence in probability. There are events that are mutually exclusive in probability. For some reason, students tend to like mix them all together. Okay? I decided this year to make them two completely different lessons so that they wouldn't be confused. They wouldn't be blended together. But because you guys haven't really officially had that lesson, because you haven't watched the video and done that homework, that the idea of independence is going to be new to you today as well. So just try to keep them separated. So the concept mutually exclusive. Two events are considered mutually exclusive if, when the first event happens, that absolutely prevents the second event from happening. Okay? So when I roll a die, if I'm only going to roll it once, if the two events are landing on a 1 and landing on a 6, and I land on a 1, can I also land on a 6 if I'm only rolling it one time? No, the 6 is all the way down there. I either land on the 1 or something completely different, or I could land on the 6, but landing on the 6 would exclude the possibility of landing on the 1. Does this make sense to everybody? Okay, so those two events, landing on the 1 and landing on the 6, are mutually exclusive. But if I roll 2 dice, and the two events are landing on a 1 and landing on a 6, are they mutually exclusive? If this one lands on a 1, does that prevent this one from landing on a 6? No, not at all. They have nothing to do with each other. There is no consequence whatsoever, even if it's just the same die, but rolled twice. Does landing on a 1 the first time prevent me from landing on a 6 the second time? No. So they're only mutually exclusive if it's just one die, one time. Does everybody understand that? Kind of, sort of? Okay. Another question that's super popular with mutually exclusive events. So, in a shuffled deck of cards, how likely is it that the top card is the Queen of Hearts? Second event, the bottom card is the Queen of Hearts. Are those two events called mutually exclusive events? The top card being the Queen of Hearts, the bottom card being the Queen of Hearts. Are they mutually exclusive, yes or no? You guys. Yes or no? So, what are the two events again? Repeat them back to me so I know you can hear. Okay, so in this, I'm not touching it. In that deck of cards, that is a complete deck of cards. It has been shuffled-ish, except that I just manipulated it a little bit. 2 events. Event number 1, the top card is the Queen of Hearts. Event number 2, the bottom card is the Queen of Hearts. Are they mutually exclusive? What's the top card? The Queen of Hearts. Does it prevent the bottom card from being the Queen of Hearts? Yes. If I have these cards and they're all shuffled, and the top card is the Queen of Hearts, is it possible for the bottom card to also be the Queen of Hearts? No. Why? Why are they mutually exclusive? There's only one Queen of Hearts. She can only be here or somewhere in the middle. She can't be in both places at one time. Do you understand now? Okay. Good talk. Because the first event happening excludes the likelihood, excludes the possibility that the second event could even happen. Yeah? Okay. All right, so mutually exclusive. The definition on your notes says 2 things are mutually exclusive when the occurrence of one prevents the occurrence of the other. Okay, the exclusive word, you could use that as a reminder that one event excludes the other. Okay, so here's another example. It says, draw a card off the top of a shuffled deck. So, you have your shuffled deck of cards. Oh. Okay, shuffled deck of cards. I haven't touched it. It says you're going to draw a card off of the top of the shuffled deck. The first event is that the card is a heart. The second event is that the card is a spade. Are those 2 possibilities mutually exclusive? So if this card is a heart, can it also be a spade? No. The fact that it is a heart excludes the possibility of it being a spade. Feels a little bit like a magic trick when it turns out the way I want it to. A little bit. Feel kind of cool right now. I'm just going to soak it in. Okay. You guys are no fun today. Like, seriously? Seriously? Really? Is this going to change the atmosphere in the room? Huh? No? This room sucks. You might want to leave. They are so boring. They've been giving me the silent treatment. They don't laugh at any of my jokes. They were not even impressed when I said this card was going to be a heart, and look, it was a heart. I want to go home. Okay, sorry. We continue. I can't believe I'm recording this lesson. These poor people that are watching it are like, yay, okay, stop talking. All right, sorry. So, mutually exclusive. If it is a heart, it cannot be a spade. If it is a spade, it cannot be a heart. Doesn't necessarily mean that it has to be one or the other, but it's saying if one of those events happens, it excludes the other one from happening. Okay? All right. The next thing we need to talk about is the addition rule. In the first half of the notes, in the first half of the probability lecture, you learn about the multiplication rule. The multiplication rule is used when we want 2 events to both happen. Okay? So when we're using the multiplication rule, we're looking for the keyword and. I want this to happen and this to happen. And if that's what you see in your probability questions, then you would multiply those 2 probabilities together. In this situation, the addition rule is talking about when I want one thing or another to happen. Those are different, right? Yes? If I want mashed potatoes and gravy, that's different than mashed potatoes or gravy. Slurp it up. That's so gross. Okay, anyway. Yeah? Those are different. And with probability, they are also very different. If you want both things to happen, or if it says this and this, then you multiply. The addition rule tells us that if the word is or, it actually says if you want at least one thing to happen. So it says, to find the chance that at least one of the two things will happen, check to see if they are mutually exclusive, and if they are, you're going to add the chances. Okay? So over here, we did this. We said at least one tail. And then we also said tails on the first or tails on the second. Those are asking the exact same thing. Those phrases kind of sort of mean the same thing. Okay? In the addition rule, you only take probabilities and add them together if they are mutually exclusive, because if they're not, then you're overcounting. Your total probability will be too high. Okay, so let's look at how this works. Let's just go ahead and keep going. So the next example on your note guide says, what is the probability of drawing a heart or a spade off the top of a shuffled deck? So probability of a heart or a spade. So here's what I want you to do. When you see this word, you know you're going to use addition. Okay? What is the likelihood in a deck of cards? What is the likelihood that any given card is a heart? There's also a mini lesson about what's in a deck of cards in that first lecture if you need it. So what is the likelihood that one of those cards that I randomly draw, what's the likelihood it is a heart? How many hearts are there? Out of how many cards total? 52. So the probability of a heart is 13 out of 52. The word or tells me that I'm going to add these two things together. Now, what's the probability that that top card is a spade? How many spades? How many cards total? 52. Anytime you have written addition, then you need to stop and you need to ask yourself, are those two events mutually exclusive? So you read the problem again and it says you're only taking the top card off of the deck. So there's only one card. Can it be both? That is the question. Anytime you write this, you pause before you put an equal sign and you ask yourself the question, can both happen? If it is only one card, we're only talking about that top card, can it be a heart and a spade at the same time? And the answer is no. So they are mutually exclusive, which means we're done. We add these together, 26 out of 52. If we simplify that, we get 1/2. Someone please explain to me why the answer to this question is simply 1/2. How many of you know your decks of cards? Ashlyn, why is it 1/2? There are 4 suits, and I wanted to know if it was what the likelihood is that it's one of these 2 suits. That's half of the cards in the deck. So the probability is 1/2. Fancy way of writing it. This is just thinking it through. How many cards are there that are a heart or a spade? There are 26 hearts and spades out of 52 cards total. Okay? Next question. We're gonna skip the fact that it words it in true false format. I just want you to answer this question for me. What is the chance? So this is a pair of dice. So you've got 2 dice this time, right? What is the probability of getting at least one ace. That's just when the side of the dice with just one dot shows. So if I roll it twice, what is the likelihood that I get at least one of them to be an ace? Okay. Let's look at this that we already have. What is the likelihood? So look at all of the possibilities for the outcome when you roll two dice. And it says again, what? What is the chance of getting at least one ace? What's another way we could word that? Could get an ace on the first die. Agreed? Or, what's the other option? Get an ace on the second die. Is that the same as this? Yeah, asking the same question. Because I threw the word or in there, that means I can add the probabilities together. So let's try it. What is the probability of getting an ace on my first roll? What is it? 1 out of 6. Thank you. Or tells me to do what? Add. Say it. Or says add. Do it. Or says add. Okay, thanks. I'm just trying to help, you know. Okay. Okay. Or ace on the second. What is the probability of getting an ace on the second roll? Also 1 out of 6. And then I always stop. Do not put an equal sign until you ask yourself the question. What is the question? Can both happen? Yes. So that is not going to be our answer. We have to fix it. Let me show you what it looks like when we fix it. So you have all of this data, all these ways that we could roll the dice. Now you have it on your paper, so I'm only going to write down the parts that I actually need. Probability of rolling an ace on the first. That's all these, right? Don't these all have an ace on the first roll? Yeah? Okay. So there are, if we look at these, all these rows are actually the same size on your actual notes. So there's one row that was a success out of 1, 2, 3, 4, 5, 6 rows. So does this number make sense to everybody with the diagram? Okay. This one says, what's the probability of an ace on the second roll? Isn't that all of these? Again, 1 out of 1, 2, 3, 4, 5, 6 columns. Look at that picture. What do you notice? What have I done? I selected all of those, and I selected all of those, and in that process, what have I done? I picked one of them twice. I'm counting this twice. Right? Does everybody see that? That follows both of these stipulations, an ace on the first roll, and it also follows ace on the second roll. So it got counted in this one and in this one. So my true answer, really, if I just look at it, of all the things in the layout that have a 1 in them, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 36 that have a 1 somewhere in their combination, right? That should be my answer. If I add those together, I get 12 out of 36. So this number is too big, and it's because of this. Can both of them happen? Yes. Both of them can happen. So because both of them can happen, the place where they both happen is counted twice when I add these together. So what I have to do to fix it is subtract it back off. So what I do is I subtract off the probability that both of those things happen. Okay, so last time's lesson we talked about what is the probability of getting snake eyes or an ace and then another ace. In that case, I would multiply the probability of an ace times the probability of an ace. What is that? If I multiply those, what fraction do I get? 1 out of what? 36. Does it make sense to you that that is represented by this spot right here? Is that 1 out of 36 possibilities? Does it make sense to you that if I just subtract that off, then these don't overlap anymore? It just is now saying, okay, it's all of these and all of these. But if I subtract that off, I'm no longer counting the 1, 1 twice. Yeah? Okay. So in your notes, it shows you there's a fancy way of writing this. They write it as the probability of A or B. So event A or event B happening is the probability of event A plus the probability of event B minus this fancy thing. Anybody know what that means? Well, what did we just do? We got rid of what? If this is event A, an ace on the first roll, and event B is an ace on the second roll, we got rid of the event when what happened? When both of them happened. Okay? So there's two ways to think about this. Sometimes we say probability of A and B. Sometimes we use that symbol and say it's the word and. Technically in math, this is the word intersection. It's where event A and event B intersect, which you could see, like actually see, this event intersects this event right there. We're literally just getting rid of that overlap. Okay? What it boils down to is that this is going to be the probability of event A times the probability of event B. When I want both things to happen, I multiply their probabilities together. So what you will see in your calculation is 1/6 plus 1/6 minus 1/6 times 1/6. Those are those numbers right there. Same numbers. Just doing different things with them. Okay? All right. So it goes through all of that. Oh, so true or false? The chance of getting at least one ace is 1/6 plus 1/6. False. It is this. It is 1/6 plus 1/6, which would be 2/6, but I need to take off 1/36. If I'm all about my common denominator, that gives me 12 minus 1. So the true probability is 11/36, not 1/3. Good? Maybe? Okay. So when you flip the page over, it asks you the exact same question again. Sorry about it. I might have been tired when I made this note guide. It says someone throws a pair of dice. What is the probability of getting at least one ace? Okay, here's what I want you guys to get in the habit of. When you get questions that have multiple events happening, like throwing a die twice, I want you to ask yourself these questions. Question number 1. Can I write the question with the word or? So when it says, what is the probability of getting at least one ace, can I rewrite that question using the word or? The answer is yes, because I could write it as what's the probability of getting ace on the first or ace on the second. That would be at least one ace in the mix. So if that's a yes, you go to the next question. Are the events mutually exclusive? Is getting an ace on the first roll and getting an ace on the second roll, are those two events mutually exclusive? And the answer is no. For this one, the answer is no, which means you would not proceed to question or to part 3, or you proceed with caution. So if yeses, if they're both yes, if they are both yes, just add. Okay? But if 2 is a no, you have to add and what else? And subtract. You have to add the probabilities together, but then subtract off any overlap that would exist between those two probabilities. Okay? All right. Let's just go through. We'll just talk about these other questions. Did you know I hate people? Mostly sophomores, but people that are super annoying and loud in the hall when I'm trying to teach. Yep. I hate them. Okay, so the first question that I need you to answer on your page, I'm not going to write it up on the board, you can do it. What is the difference between mutually exclusive and independent? Well, we haven't talked a whole lot about independent because that was last time's lesson. What does it mean for two things to be independent? Yeah, like they're off on their own. When you guys are independent, who is no longer making your decisions for you? Mom and dad. You make your own decisions, okay? So in probability, 2 events are considered independent if the first event doesn't influence the likelihood of the second event. If you flip a coin, does getting heads the first time you flip that coin influence the outcome of the second time you flip the coin? No, not at all. When you roll a die, does what you get on the first roll influence what you get on the second roll? No, it doesn't. Okay? But when I'm dealing cards, does what I give you as your first card, a 9 of diamonds, influence what I could possibly give you on your second card? Yeah. Okay? It decreases the chances that this one is a diamond and kind of sort of increases your other chances. Okay? It also prevents this card from being the 9 of diamonds. It can't be now. So is this second draw independent of the first draw? No, it is dependent. The second draw depends on what happened on the first one. If you know what happened. Now, if I didn't tell you, if I just gave you a card Does this being on the table influence what is here? The answer to that question, so that's a little tricky, but the answer to that one is actually no. Even though that card is already there, when I'm talking about probability, I'm talking about chances. If I don't know what that is, it hasn't influenced the chance that this card is, let's say, the Queen of Hearts. It doesn't matter until I know it. As soon as I know it, oh, it's the Four of Clubs. That makes it a little more likely that this is the Queen of Hearts. Now it's a 1 in 51 chance instead of a 1 in 52 chance. Okay? But if I don't know it, then the two events are technically independent of each other because this one isn't influenced by this one. It might as well still be in the deck. Okay? Kind of a weird concept there. Okay. So independent just means that, so if two events are independent, then the outcome of the first event does not change the probability of the second event. Okay, so if you need to write that down, I'll say it one more time. So independent, the outcome of the first event does not change the probability of the second event. What is mutually exclusive? In your own words. What does it mean for two events to be mutually exclusive? Hello? 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 Testing, testing, 1, 2, 3. Can you hear me? Somebody, in your own words, what does it mean for two events to be mutually exclusive? Go. Yep. If one of them happens, the other one cannot happen. Okay, next question. When should I add probabilities and when should I multiply? What did we learn today? We add probabilities when we encounter the word or. When do we multiply? The word and. Okay, we could make that a much longer explanation. We add probabilities when we want at least one of the events to happen. We multiply probabilities when we want both of them to happen. Last question. How do I know if the multiplication and addition rules can be used? Well, we learned today that you're only allowed to just add and not worry about it and stress about it if what condition is met? You can only add if what? The two events are mutually exclusive. So you can only add if the two events are mutually exclusive. Otherwise, you have to add and subtract. And when can you multiply? Only if the events are, what would you guess? Independent. We only multiply events that are independent. Otherwise, we have to multiply by what's called the conditional probability, which you'll learn about when you watch the other video. Okay, let's do these 4 examples, and then you can work on your assignment. So it starts out by telling us that, first of all, there's going to be a die. We're going to roll it 6 times just for kicks and giggles. Second thing that's happening is we have a well-shuffled deck of cards available to us. So the first question, calculate the chance that the first roll is an ace or the last roll is an ace. All right, what is the probability that the first roll, remember there are 6 rolls, what is the probability that the first roll is an ace? 1 out of 6. What word, what key word do we have here? Or, so what sign should I put there? Next question, what is the probability that the last roll is an ace? If I've rolled it 6 times, and I already got an ace on the first one, are you sure I can still get an ace on the 6th one? Yeah, I can. Okay? So I add them together, and then I immediately stop myself because I need to ask a question. What is the question? Can they both happen? And the answer is yes. So these are not mutually exclusive. So I need to subtract something back off. Okay, we've already done this, you've already seen it, but what I finish with is I subtract off the probability that I got a ace on the first roll times the probability of an ace on the last roll. Altogether, you've seen the math over there. Our final answer is 11 out of 36. Any questions? Okay, question B. Calculate the chance that the first roll is an ace and the last roll is an ace. What is the probability that the first roll is an ace? 1 out of 6. Keyword. And tells me to do what? Multiply. Now stop right there. This one, the stop to ask yourself a question is right here before you ever write that second number down. This number that you're about to write right here is the probability of the last roll being an ace if the first roll was already an ace. Okay? This is the part where you're asking yourself, are these events independent of one another? Are they? Does what you get on the first roll of the die influence what you get on the last roll? No, so they are independent of each other. This is just a way of asking or covering your bases. What is the likelihood of getting an ace on the last roll if I already know that I got an ace on the first roll? Still 1 in 6. Okay, that second probability wasn't really influenced at all by what happened in the beginning of this, and it's because those events were independent. Now, if this had been different events like pulling colored marbles out of a box and I took a marble out on the first event and I didn't put it back, then the probability of this second event happening would be impacted by the fact that that already happened. And I have to consider that when I write that next probability down. In this case, it doesn't really matter, okay? So our answer is just 1 out of 36. Good? Okay. Part C. Calculate the chance that the top card is the ace of spades or the bottom card is the ace of spades. So the probability that the top card is the ace of spades. So how many ace of spades are there in the deck? 1. And how many cards are there total in the deck? So what is the likelihood that the top card is the ace of spades? 1 out of 52. Okay, then what's your key word after that? Or. So what symbol are you going to put there? Add. Then what do you have to do? What's the next part of the probability? What's the likelihood that the bottom card is the ace of spades? So top card is the ace of spades, has a probability of 1 in 52. Keyword was or, so we add. Now, what is the likelihood that the bottom card is the ace of spades? Also 1 in 52. Okay? But then we ask ourselves the question, what? Can they both happen? Can the top card and the bottom card both be the ace of spades? No, which means they are mutually exclusive. They are mutually exclusive, so no subtraction needed. So the probability that the top card is the ace of spades or the bottom card of the ace of is the ace of spades is 2 out of 52. Now, does that make sense? The ace of spades, that's clubs. There it is. Okay. In a well-shuffled deck, where could the ace of spades land? Could it land up here? Sure. Could it be in the second spot? Could it be in the third, fourth, fifth? Could it be in the 52nd position down here on the bottom? So there are 52 places where this card could be. Does that make sense to everybody? And we are asking the likelihood that it's in either the first or the 52nd position. So 2 of those would be successes out of 52 possible spots. So just a different way of thinking about that question. I notice with probability, the more ways I can get you to understand those numbers, the better, because probability is hard for some people. Okay, last one. Calculate the chance that the top card is the ace of spades. Oh, that's a S, obviously. This time, and what? The bottom card is the ace of spades. Some of you might have wheels turning a little bit, but I want to do this one the same way we did all the other ones so that you can always do it the same way. Okay? Probability that the top card is the ace of spades. What is it? 1 in 52. Keyword this time tells us to. Now remember, if I'm using multiplication, before I can write that, I have to make sure it is the probability of this event happening given that this one already took place. You can't. Can the bottom card be the ace of spades if the top card was already the ace of spades? So if it can't happen, what's the probability? 0. Okay, so that second one is the probability that the bottom, you'll see this notation when you do the other assignment. It's the probability that the bottom is the ace of spades given that the top card is the ace of spades. And the likelihood of that happening is 0 because that ace of spades is already in a position. It can't be in both spots at the same time. So the final answer to that one is just a big fat 0. 1 out of 52 times 0 is just 0. Okay, so the assignment that goes with the notes that we just did is the gold assignment. Afterwards, you can, if you still have time, you only have 15 minutes. So I would just hurry and knock out your gold assignment if I were you in the 15 minutes you have left. And then make sure that you watch the video and fill out your first half of your notes and do your pink assignment so I'm going to post the quiz, make the quiz available. Actually, I might just make it available tomorrow. So it's available Wednesday, Thursday, Friday. Okay, so make sure you get your quiz done before you leave for Christmas or you'll be sad. Any questions?